Okay. Now, solving a one-step equation. All right, you're just doing the inverse. All right, we've discussed this. All right, so everybody should remember. How am I getting rid of 3.2?
Divided by 3.2.
Yes, I want everybody to put divided by 3.2 and then divide by 3.2. All right, now I'm really, can anybody look at that and say, well, obviously X is 8. That is very good. All right, now, again, what we're going to do is we're going to take a look at it. Hey, come on, we're good. All right, yeah, he's smart. All right, he just needs to concentrate more in class. All right, now this, I would like everybody to remember, you're moving the decimal over. So the first thing I want everybody to do is put 256 over 32. All right. Now, does everybody agree? I don't feel like doing the division, right? So I want you to be able to look at that and say, okay, I know it's divisible by what? I know it's divisible by 8. All right. So let's go ahead and divide by 8. If I divide by 8, what's 32 divided by 8? 4. And what's, how many times does 8 go into 25? 3. Come on. I'm not interested in playing around. All right, 3 times. Now there's a 1 left over. So 8 goes into 16 how many times? 2. Everybody see that? All right, you don't need a calculator for that. Now you've broken it down to 2 numbers you can do quickly, right? 32 divided by 4 was what? 8. There you have it. All right, without a calculator, that's good. Yes, sir.
I don't understand how you instantly knew it was 8.
Well, some people don't. You don't have to. All right, you could have divided by 2 or divided by 4 or divided by 8. You with me on that?
Mm-hmm.
So again, that's a good question. All right, that's a good question. He just thought it was divisible by 8. You with me?
Mm-hmm.
All right. Now, let's take a look at question number 3. All right, same kind of deal. We're just dividing by what? This time dividing by what? Negative 4.5. Dividing by negative 4.5. Now, this is what I'm expecting to see when I collect your work tomorrow, okay? You're showing me what you're doing. So now I know F equals. Now, in this particular case, all right, I still have to move the decimal over once, correct?
Yeah.
So this is the same as 45. There you go, 180.
You can divide it by 5.
Actually, I think there's even a better one we can divide it by. 9 is something better. Now, I'm not saying you can't divide it by 5. That's true. But I like dividing it by 9 because 9 goes into 18 easily. And 9 goes into 45 easily. So when we do that, 9 goes into 18 twice with the 0 left over. And then this is just negative 5. So now what's 20 divided by negative 5? Negative 4. Please sit up and make sure you're understanding me. All right. I can't tell you how critical this is, guys, and I mean it. All right. Your understanding of numbers will help you next year. All right. I don't want you just not understanding how you can do math in your head. All right. What?
Did you get 180 from doing an adjustment?
Yes, that's right. Thank you for asking that, buddy. All right. So this is what I want you to remember. 18 is here, right? Decimal. Move it over 1. That creates the 0.
And the 20.
I divided by 9. I divided each of these by 9. Mr. Ward, are you happy with that?
Yeah, so for the dividing by 9, like use 5 as a number.
Yeah. I said 45 and 18. Both are divisible by 9. You with me on that? All right. That's what I'm trying to get you to do. All right. So here we go. Let's take a look at number 5. Now we're doing the fractions. How do I undo addition? Yes. So on this problem, I want everybody to put a -1/2 and a -1/2. Now, with fractions, we have to remember to get common what?
Denominator.
Yeah, for addition and subtraction, we'd common denominator. So what is the common denominator here? 6. All right, now once again, we're kind of speaking out loud because I feel like we've spent a lot of time on fractions. So I'm kind of reviewing. But if you're not sure, you need to tell me. We said the common denominator is 6. So 2/3 is how many sixes?
4.
4. Because remember, we multiplied by 2, correct? Now, 1/2 is how many sixes? 3/6. Now, please do not sit there and go, man, I know I'm supposed to know, but I don't. I forgot. Anybody have any objections? Tell me.
I just don't remember this and I got 3/6.
Because I multiplied the bottom by 3, I have to multiply. That's good. All right, now you're back. Now you're back. Come on.
Oh, never mind.
I multiplied this fraction by 2, and there you have it.
Oh, and why would you have to multiply the one on the right if it's already 3 in the bottom?
Because you're trying to make it a 6. You're trying to get common denominators.
Oh,
You with me on this? So that's why I'm multiplying by 2. And so again, your final answer now is 1/6. All right, so again, I'm trying to make sure everybody is experts at fractions and decimals. All right, so you gotta speak up now. All right, let's check out number 7. All right, so now,
Did you get 1/6 by subtraction?
yes, ma'am, because it's 4 minus 3, correct? Is that good?
Yeah.
All right, so everybody's got to stay with me now on number 7. Now I have to add what? 2 1/4. Anybody have any issue with that so far? All right, now these cross out, so y equals. All right. Now, am I going to add or subtract these fractions? Subtraction. Right, now is the answer going to be positive or negative? Positive. Exactly. All right, now, because we're subtracting, it's better if I put the 2 1/4 on the top and the 3/4 on the bottom. Now, do I have a common denominator?
Yeah.
Yes, tell me.
So it says y minus 2 1/4. So with that, why wouldn't it be negative?
Because remember, you're working backwards. You're working backwards.
The negative would belong to the y.
Well, let me make sure I'm saying this correct. Let me ask you this. If I just said y minus 2 equals 3, what would I do to solve this?
Oh, it would be 5.
Right. So to solve it, we would add 2. You with me now? All right. So now I'm over here going 2 1/4 minus 3/4. Can I do 1/4 minus 3/4? No, we had to what? We had to borrow from the 2. We make that a 1. Now, the hard part was not really hard because we've done it so much, is the 1 there now becomes a 5. When you borrow for fractions, you must remember that you're adding the numerator and the denominator. So that becomes a 5/4. All right, that's why we're reviewing. Now, again, 5 minus 3 is what? 2/4, and we're left with 1 2/4, which everybody knows reduces to 1 1/2. Now, I really like the way we're doing this, okay? It's your job to speak up when you don't know. Tell me.
You're adding your.
Well, one is positive and one is negative, correct?
Mhm.
If one's positive, one's negative, you're always going to subtract. If the signs are the same, you always add. Okay?
But if, like, it would be y minus 2 1/4, why would you add and not denominator?
It's kind of like, well, because it's not multiplication. The inverse of subtraction is what? Addition. Right, so let me say this again, just to make sure maybe I wasn't too clear. So look up here. Today, you're going to have addition, you're going to have subtraction, you're going to have multiplication, you're going to have division, and you're going to have, for example, a fraction. All right, please listen. So if I'm working backwards, how do I undo addition? Yes, very important. To undo addition, we're going to do subtraction. To get rid of subtraction, I do what? Addition. This is multiplication. How do I undo multiplication? You're going to do division. How do I undo division? Multiplication. And how do I undo a fraction? What was the word? Reciprocal. We do the reciprocal to undo fractions. All right, you multiply by the reciprocal to undo a fraction. All right, this is the thing you need to understand. All right, we're really trying to train your brain to work backwards. All right, so hopefully that helped. All right, with that little bit of information now, let's go back to number 9. Now, does everybody see what I just said? We have a fraction here, correct? So I'm going to do what?
So you're gonna do reciprocal.
Right, I'm going to do the reciprocal. All right, I'm just writing this out again so I can get the reciprocal in here without you. So what's the reciprocal of 3/8? 8/3. So I need everybody to put 8/3 here, and I need everybody to put 8/3 here. Now remember, no calculators. So what happens now to the 3 and the 8? They all become 1s. That's correct. So now we have the variable n equals. Now, again, we should do the division first. What's 24 divided by 3? 8. 8 times 8. 64. Now is the answer, Wilson, just what are you doing?
What?
I'm asking you what you're doing.
I was getting on notability.
Okay, well, we're doing it on paper, not notability. So get rid of the iPad. All right, I feel like you're not following me. I feel like you're, doing something you shouldn't be doing. That couldn't possibly be, I understand. All right, that's why I was questioning. So what is the final answer here? N equals? Yes, -64. Anybody have any trouble with this? Tell me.
Would it be negative if it's negative?
Right, negative times a positive is a negative. All right, yes.
How'd you get 64?
So let's do this together. What does this fraction bar mean?
Divide.
So I did 24 divided by 3. What's that? Then I multiplied by 8. 64. All right, anybody else need a better explanation?
Yeah, I need a little better of one.
Well, all it is the order of operation, right? All we're doing is your understanding of what you actually are physically seeing when I say 24 times 8/3. I don't feel like doing 24 times 8 because it gets bigger. It's easier for me to do the 24 divided by 3 first,
Oh, that makes sense. Thank you.
and then I'm multiplying by 8. We got lots of example problems. That's why I'm asking. All right, over here, now I have a really ugly one. I'm dividing by what?
9.7.
Yeah, I'm going to divide by 9.7. -9.7, -9.7. And so now I want everybody to put H equals. Is it going to be a positive or a negative?
Positive.
Tell them why.
Oh, because a negative times or negative times a negative is positive. Positive times negative is negative.
That's correct. Same properties apply. We're dividing. A positive divided by negative is definitely a negative. Is everybody with me? All right, now I really don't like this number. So let's change it to 873 divided by 97. Now, the reason why this one is annoying is because I don't see that I can even break 97 down to something I can divide both of them by. But I can make an educated guess on this. All right, so I'm trying to show you how I know what the answer is. All right, what? What is it? What's 873 divided by 97?
100.
Of course, everybody should say 9.
Yeah.
Pretty confidently. Now, How did I know that? All right. I'm not even saying I'm right. I'm just saying I think I'm right because why? Listen, everybody look up because it's not a mystery. It's not like I am magical with numbers. I don't have the numbers memorized. I have thought about the numbers, and that's what I'm trying to teach you. I don't care about the memorizing. You should be able to look up there and say, how many times does 9 go into 87? How many? 9. Now, I thought I was correct because 9 times 7 ends in a what?
7.
Ends in a 3. Shh, come on, I don't care. I don't care. I want people to speak freely. 9 times 7 is 63. That's why I think it's 9. So once again, let me say that again. So you'll know you don't need a calculator. 9 goes into 87 how many times? 9 times. And then I thought, well, 9 times 7 ends in a 3. So I feel pretty good about that. All right. So now I'm just going to say to myself, okay, what's 97 times 9? That's not hard. 9 times 7 is 63. 81 plus 6, 87. So everybody see that? All right. You can do that. Everyone in here needs to be able to do that if you're going to be good at higher level math. All right. You don't need a calculator. All right. You don't need a calculator. All right. Now let's check out 13, please. Okay. So now again, we're undoing subtraction. How do I undo subtraction? Addition. So everybody's going to put plus 4/5, plus 4/5. Now this one's a little bit easier because they're both positive, right?
Yeah.
So we're just adding them just like we did in 5th grade and 6th grade. And now you're almost in 8th grade, so this should be no problem at all. The common denominator is, of course, 15. All right. Now I'm multiplying the first fraction by 5. So the numerator becomes 10. Multiplying the second fraction by, so the numerator becomes 12. All right. Now, if you don't know that, or if I need to review it, I don't mind. What?
You get 2 4/4.
I'm adding 4/5 to both sides. So they cancel on the left side. All right. That's what we're doing. All right. We're undoing addition. We're undoing subtraction, multiplication, and division. Yes, ma'am. Because I'm trying to get a common denominator of 15. So please listen, watch me. I'm at 3. I need to get to 15. What do I multiply? And I put the times 5 here and the times 5 here. And what about the bottom one?
5 times 3.
And
4 times 6 is 12.
there you have it. That's it. Yes, sir. Good for you. Welcome back to the game. Oh, thank you for catching that for me. I should just go ahead and put that over here, right? There you go. You good now, right? Okay. And now we already said we're adding. All right. So now 10 plus 12 is 22 over 15, and we bring down the 3. That's not a proper fraction. So we're going to change it to 4 and 7/15. Now, how do we know it's 4 and 17? Because 15 goes into 22 how many times? Once. So that adds to the 3 and gets a 4. And from 15 to 22 is 7. All right. Now, look, it's not going to do any good if you're not concentrating real hard and trying to tell me, because I know it's a review. All right. Anybody have any issues? Max, you're kind of quiet. Is this all good for you?
I don't really understand it.
Okay. Well, we're going to go number 15, Max, and I want you to speak up now. I'm going to let you do this one. All right, Max. How do I get rid of that 4.8? That is correct. Minus 4.8. Minus 4.8. Now, decimals, adding and subtracting decimals, you just got to remember, you got to line them up. All right, now everybody's supposed to see that this 4.8 up here is positive 4.8. That's why we did minus 4.8. All right. Now, from there, these cancel. Now, again, I really am trying to get everybody to just look at that and say 7.1 minus 4 is 3.1. Now I'm subtracting another 0.8. So I subtract 1 and I get 3, then another 0.7. So that's going to be 2.3. All right, that's how I kind of want you to see the numbers. But of course, you don't have to do that. You can just say, I take the 7, make it a 6, make this 11, and that's totally fine. Yes, ma'am.
You get the 0.8 from 4.8.
Yes, right. I subtracted 4.8, subtracted 4.8. You with me?
Yeah.
Okay, so now, Max, I hope I didn't go too fast. You okay with that one?
I think I got it.
Yeah, the decimals are a little bit easier, okay? So now let's check out number 17. Again, I'm throwing a couple more decimals on here. So now I need to see, all right, Max, what operation holds these two things together here?
Multiplication.
So how do I get rid of it?
You have to divide.
That's right. I'm dividing by negative 1.5 divided by negative 1.5. So F is equal to, is the answer going to be positive or negative? Definitely negative. Now, I want everybody to come over here and say 165 divided by 15. Now, I just want everybody to look at that and say, obviously, it's 11. Obviously, it's 11. There's just no other way. Your brain should look at that and say, that's 11. All right. And those of you guys who's sitting there going, I don't know what you're talking about. How many times does 15 go into 16? Once, with 1 left over. 15 goes into 15 once. What? Shh.
I'm sorry, but I thought it was plus 1.5 because.
I know, but that's why I said specifically what operation holds these two numbers together. Multiplication holds them together. So we have to do what? Divide. So I said at the beginning, to eliminate addition, we got to do subtraction. To eliminate subtraction, we got to do addition. To eliminate multiplication, we got to do division. To eliminate division, we have to do multiplication. And fractions multiply by the reciprocal. That's what we're thinking. All right, so we got some more time, so let's knock this out. All right, so again, I have 1/3. So I just said, how do I get rid of a fraction?
Oh, the reciprocal.
Reciprocal, what's the reciprocal?
1/3.
The reciprocal.
Oh, 3/1.
Yes, 3/1 times 3/1. Just leave it like that. All right, now everyone should look at the 1/3 and the 3. What do they do to each other? They cancel out always. That's why you do that. All right, now we're going to look carefully. D equals, is the answer positive or negative? It's definitely negative. Now, everyone should be looking at this saying 3 goes into 3 and 3 goes into 6. 3 goes into 3 how many times? Once, and 3 goes into 6 twice. So my final answer is -1 what? -1/2. Yes.
Well, couldn't you just look at the problem and say it's dividing and just do that?
I'm with, this is how I want you to do fractions, right? I look at that and say, obviously, the answer is -1/2, right? So I'm totally fine with that. But again, I just don't want mistakes. I'm trying to get across your head, multiplication, division, addition, subtraction, multiplication. Fractions are reciprocals. Tell me.
How do you know when you do the reciprocal or if you just do like?
Well, see how this is held together by multiplication, right?
Mhm.
So whenever there's multiplication, it's a reciprocal,
Okay.
right? And that's why I say there's so many practice problems here. You're going to be fine. Like, look at number 20. That's 1/15 times R, right?
Yeah.
So I want you to think reciprocal.
Okay.
Whenever there's a fraction in front of the number, it's the reciprocal.
But what about 17? Why didn't we do the reciprocal for that one?
Well, because this,
Oh, it's a decimal.
that's right. That's right. You're getting it. All right, here we go. let's try 21. All right, now, for whatever reason, this was a tricky topic. All right, but tell me what I'm going to do for this one. Let's see, Lila.
It's subtraction.
Right,
So you would add,
that's right. So I'm going to add 8 3/4. Going to add 8 3/4. Now, this is about as easy as I can make it for the fractions. These two things do what to each other?
cancel out.
Right. So you should be able to tell me easily y equals,
2 3/4.
we're adding, right?
Or I meant, 14.
Yes, there you go, kid. 14 3/4. Max, a little better?
Yeah.
All right, come on, concentrate for me. All right, let's knock out 23. Okay, 23's. All right. So, Mr. Ward, what am I doing? That's correct. Very nice. Minus 4 3/4 minus 4 3/4.
So would it be 10 and
Oh, I'm so happy. Almost correct. Almost. All right, you are correct. It is -10, right? Because we added. But you still have to add these two things together. So 3/4 plus 3/4. No, 6. Remember, when you're adding, does the denominator change?
Oh,
Right, you see what I'm saying? If you have 3/4 in your pocket and 3/4 in your other pocket, that means you have 6 quarters altogether. That's how I thought about it, all right? 3/4 plus 3/4, you have 6 quarters.
I thought it was subtraction. What happened?
When the signs are the same, the rule is you add them. You're adding. All right, now, of course, we have to fix 6/4. We have to reduce it by 2. So I want everybody to say y equals -10 and 3/2. And then everybody's got to be able to talk to me about this 3/2. Thank you. -11 and 1/2. -11 and 1/2. All right, tell me. Remember, I divided by 2. Yeah, I reduced the fraction. Good questions.
How do you get 1/2 again? Oh, wait, never mind.
3/2, 2 goes into 3 once with 1 left over. All right, here we go. 25. Again, everybody should be looking at this saying it's multiplication with the fraction. So what am I doing? Well, you can actually, you actually can divide, but I prefer you say what? Reciprocal. All right, what's the reciprocal of -1/8?
-8.
Right, -8/1. Do I technically have to put the over 1? No, because that just means you're multiplying by 8. All right, now these two guys cancel out. Negative times a negative is a, so final answer 8. Final answer is 8. Okay,
Yeah.
all right, here we go. Now 27, don't be scared about 27. It's automatically what? 0. Anything times 0 has to be what?
0.
The only way this can equal 0 is if P equals 0. Is everybody okay with that? 1/6 times 0 is 0. That should just be automatic. Should be automatic. All right, here we go. Let's check out 29. Okay. Now, Max, on this one, what do I do? You add 1.2. Add 1.2. Now notice I'm lining up the decimals for those of you guys who forgot. So X is equal to what? Yep.
2.95.
Yes, sir. 2.95. All right, let's knock out 31. Okay, so for 31, Maggie, what am I going to do?
3 + 9
Yes, you're just going to do +9. That's exactly correct. 13.21. Notice if you want, you can put 9.00. Okay. All right, let's take a look at 33. Okay. Once again, I have to do what? Divide by 2.8, 2.8. Now this one's kind of annoying. All right. So R is equal to. Now, to me, I like to move the decimal 2 places this time. 2 places this time. So that's going to be the same as 168 over 280. I want everybody to do that. Make sure you're seeing that. Right? With a fraction, you can't have a decimal. So you always move it the same number of decimal places. Now, can anybody see what 2 numbers go into both of those fractions? Obviously. I can't see 7 as much as I can see what? As much as I can see 4.
14.
Right? I like 4. Now look up there on the boards. Let me show you how I knew it was 4. Even though Mikey is right. All right. 7 does, but I think 4 is easier to see. Now, why am I saying 4 is easier to see? Because 4 goes into what? And it goes into, and 4 goes into 28. All right. That's why I'm looking at that saying obviously 4. All right. So now I'm going to reduce that fraction. And when I reduce that fraction, 4 goes into 16. How many times? How many times does 4 go into 8? 2. 4 goes into 28. And there's an extra 0. Now you're staring at 42 and 70. So you should look at that and say, well, I know that's reduced by what? 7. All right. So 7 goes into 42. And 7 goes into 70, 10. And then finally, final answer, 6/10 reduces to 3/5. All right. So again, that was very annoying. All right, very annoying. All right, but that's what I want you to be able to do. You don't need a calculator for that. What?
I got 6. I tried plugging it in, it still works out. Unless they-
2.8 times 6. 2 times 6 is 12. No, look, don't, you don't have to do it again. Look right here, what I'm telling you. If I put 6 in, I know that just 2 times 6 is what?
Well,
It's way more than 1.68.
I did 16.8. Oh, I did the wrong one.
That's all right.
Oh,
All right, let's knock out 35. Okay, one more time. What do we got here? We're doing a reciprocal. And again, what is the reciprocal? Close. Yes. Now, do I really have to do 12 over 1? No, let's just say I'm going to multiply by -12. And of course, everybody in here knows 12 times 12 is, and then it's negative. All right, I'm happy with that. Anybody have any issues? All right, let's continue on with 37. Another nice problem. Another fraction, so we know we're going to do the. Now, I like to put the negative out in front. And what's the reciprocal of 7 over 11? 11 over 7. So -11 over 7. Now here I try to trick you a little bit because I wanted you to think they reduce. Does this reduce?
Nope.
No. Remember, this is 11 over 1. So 11 times 11? Negative. Yes, thank you. -121. And 1 times 7 is 7. Now, when you get to higher level, we leave things as an improper fraction. So is this okay? Yes. Now you might say, well, we didn't leave it as improper fraction before. Yes, that's because we had mixed fractions. So if they give me mixed fractions, I'm going to leave it as a what? Mixed fraction. But if it's my choice, I'm going to leave it as an improper fraction. All right, anybody have any issues? All right, so let's knock out 39. Oh, this one's a tough one. All right. This one's a tough one. What do I have to do first?
You have to subtract.
Subtract 12.56, subtract 12.56. Now, again, I need everybody to understand this one's the hard one. So please, 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 there's lots of rules here. So the first thing I'm going to do, you have to remember from our good old days, am I going to add or am I going to subtract?
No worries.
One is positive and one is negative, so I'm going to what? Subtract. Now, when I subtract, remember, I want to put the largest whole number on top. So I need everybody to review that. I want negative 12 and 5/6. And then it's plus 2 3/4. All right. Now I need help with the common denominator. 12. So I'm going to multiply the first fraction by what? 2. So that becomes 10 out of 12. And the second fraction will multiply by 3. So that becomes 9 out of 12. Oh, at first I thought we had to borrow. Do I have to borrow on this one? No, because we can straight out subtract. So what's 10 minus 9? 1 over 12. And then negative 10. That was perfect timing. So what I want you to do, homework is the evens. Can you use a calculator? Yes, but you still have to show me that you know how to do the subtraction and the reciprocal. All right, that's fair. All right, that's fair. All right, guys, good job for today. Very, very good.